Hi, now let's take a practical example where we will create dynamic structures and then we'll transpose rows into columns. I highly recommend you to go back and watch my previous videos if you haven't done so, which will help you to understand a general dynamic programming. So let's get started. First of all, we need to get the structure. So we need to get the components of a structure. So let's do a structure. That would be a structure descriptor. And since we are getting it by name, that means we can get directly zmat chars. Is it CARS? Yeah, chars. So this gives an instance of that table as a structure. From structure, we can get the components. So we can say components is equals my structure, and there is a method called get components. This returns all the components. We do not really need a mandate, char name, and char value in the end. The end structure would have a Matner, unique columns from here, for example, height, width, depth, and length, and their respective values. So we will delete these three columns there. So that would be a simple delete from comp where name equals char name, and we'll save time by copying 3 times. So first is mandate, char name, and char value. Let's to compare char name and char value. Okay, so far we took a component with 4 fields. We removed 3 of them. So we end up having, where is it here? Just Matner. Now the next thing is we will read all the rows from all the records from the table. So that would be a simple select. So select star from zmat chars into we'll define the table on the fly, which would be li mat chars. So this will give us all the records in the table. Now we have all the rows, and from the row values, we will determine unique columns. So for before that, let's display this demo. So when we execute, we will see the difference. So display my mat chars. Okay. Incorrect next nesting. Oh, select from into table. So we want all the records. So table. Now next, we will find unique column values from rows. So for that, I will first of all we need to use unique group or unique material. So if I go in here, we have, even though we have 8 records, if you see here unique the combination of unique records is just 2, so 10 and 20. So we can use the new syntax ABAP 7 post 7.4, which is a group statement. So let's loop at our li mat chars, assigning a field symbol. We can define that on the fly. Mat char, we'll say group by, and the uniqueness is the mat char key material. So Matner, and this we can put it into data lg mat group and loop. So this will create this will loop on unique material records. That means the loop will run 2 times. Now this gives us the header or unique materials. Now we can loop on members. So that we can do it by saying loop at group. Our group is LG mat group, assigning field symbol. And you can use data instead field symbols if you're not comfortable. But in the end, it will give the same result. So let's call this members and loop. There's a typo. Okay, so we have unique records there. We have members here. Now, the very first thing is we need to add um, a unique record. So yeah, so hold on here. So we are going to add unique records to comp. For that, we will add first. We have a structure, so comp name, and then the member char name. This is the name. So in our case, like depth. This is a column, and then we have to define a type. Now, our type is a value, which value type is this. So we can take instance of this directly by using RTTR type. So we'll say ABAP data descriptor, and on a data descriptor we can say describe by name, and I think it has to be upper, so let's put it to upper. Come on, there's one more. Okay, so this gives us the this creates a component. Let's append this to our component table, and then we free our component. We basically garbage collection. So this will keep adding components, but not unique components. It will just keep adding. So let's put a condition here. If line exists in my comp where name equals my member char name. So if that is not true, so we'll visit back and we'll say if this is not exits. What happened here? Okay, so and so far how we are doing, no errors. So okay, fine. So basically what this does is we have material, then it will add height, then it will add weight, then it will add depth, length. Then on the second, if it finds height already exists from the previous record, then it will not add. Because we are not populating values, we don't care about the values at this point. We just care about the character names because we have to create columns. So that should be unique. So this is what this part of a code is going to do. Now, by end of this execution, we have a component table, this table, with all the required characteristics. So Matner followed by height, weight, depth, length, and so on. Now, here we will just create a structure like what we did earlier. So I would say hello struct and cl abap struct. What happened? Create. Oh, okay. Underscore. So struct descriptor and create, and then we pass our component table. So this gives us our component table. This gives us an instance of a structure, or it creates a structure. From this structure, we create reference data. So LO data reference structure, type handle, LO struct. And then we assign this to a memory pointer. So that would be data reference struct to I think we have struct. So that one, which is here. This is from the last episode. So pretty self-explanatory. Now we have a structure and we can create a table. Now creating table is also similar process, and I have shown you this in our earlier video. So ABAP table, we take a table descriptor, we say create method, and then pass the p line type, which is a structure reference LO struct. This gives us the table reference, and then basically we do the same thing, except the here instead struct, it's a tab reference, which is here, data ref tab, and handle is table instead structure. This is again li table, and this is data ref tab. Okay, so this creates a structure, this part creates a table. So my table at this point is a multi column. So I have a material from the base table plus all the characteristics. Now all we have to do is transpose the rows to columns. So for that, first of all, we will use the same approach what we did here, changing a few things. So let's copy that there. Now this is already declared earlier, so system is gonna complain. Let's get rid of that. Then we are grouping by, again, we have to group by mat group. And then here, so after grouping, we have to add the records to the table. So to this table, we will take all the records from the matcar or MAR. There's a typo from this. Let me change that to matcar. So find, that is supposed to be matcar, replace all. Okay, so matcar. So we take all the rows from matcar and we add it to this table, and during this we will also transpose. So the very first thing is to append initial line to our brand new table. This table signing the field symbol, which is assigning a work area, which is a structure, which we have defined it here. Our table is here. So after that, we can do a move corresponding to get the first key, which is a material, right? Which we have it in our mat group here. So what this line does is basically takes the mat group. This is a structure because if you see it here, we have defined a structure. So it puts the material from mat group into this structure. Now we have a material, so that's the first column. And now the members, which are characteristics, those we have to add or we have to populate for given material. So then we loop on the material group. This wouldn't change. This will be the same. But instead, we don't need this part. So let's remove that. We don't need that. And that too. So here we have members, meaning one material. So per material, we loop on this one, and for all the members of that given material. So if we look here, one per material, meaning for 10, we loop all the members, height, weight, depth, and length. So that means 4 loops. So this is the group loop here. Now we have to identify, or we have to take the characteristic name and then assign a value. So first, let's take the characteristic value by assigning a component. That component is the characteristic name. So our member has characteristic name of this structure, which is ls struct to a field symbol value. So it's a char val. So we are saying take the column and assign it to a pointer. And then we'll put a value in this pointer so it goes into that respective column. So if I say lv my char value equals my member char value. And then for safety, we can add if char value is, or char, rather not this one, this is source. So the destination is char val is assigned. So it doesn't create a dump. And then we format, save, let's activate. So far, we don't have any errors. And then at the end, let's output this. So if we say demo output display, display the li table, save, format, activate. Okay, so let's give a try. Now, if I run this program, this is ABAP day 5. Let me go there. We have here day 5, and let's run. So you can see first we have the original table as is printed here, which is basically 8 rows. And let's cancel that. And now you can see the table is reformatted or transposed from rows to columns. We have now these new columns created dynamically from the earlier data or from the table, and then transpose it to rows. Now, as an example, we have only, let me run. So we have only 2 materials with that many characteristics. I have wrote a program to append a third record. So let's append this. So now if I go in here and refresh, we see we have 3 material records. Now if I run my program, this should consider that third one. We'll see here we have 12 rows, but once it transposes, we see 3 with their respective values. Since I just duplicated 20 and I just changed the Matner, I did not change other values. So that's why we see the same duplicate values. So this is how you can transpose rows to columns. This is not really a practical example as such, but there are a lot of instances in SAP you will find where you need to transpose rows to columns. And it is very hard to do it statically or at design time. There's no way to do it. If you have dynamic columns, rows can grow. In this case, I did not really change rows. So if you see, those are common. But if I add, let's say, a new dimension here, a new char name, system is going to create a new column automatically. We don't have to change code. System will take care of creating a new characteristic. So this is how you can transpose your values in ABAP. And this is where the dynamic programming actually helps a lot. So now, so far, we have created a variable. We were able to read from memory. We were able to create structures. And then now we use that knowledge of creating structures to transpose rows to columns. Now, next, let's take the objects. In upcoming videos, let's write a small framework where we use ABAP objects to process data using dynamic programming. So thank you for watching, and see you in the next video.